So in this video we're trying to decide from some results whether we've got fair spinners. So we've got two spinners, spinner A and spinner B. And the area on each spinner is cut into four equal parts. So we've got a quarter, which is numbered 4, and that quarter is numbered 3, the other quarter is numbered 2 and 1, and the same for spinner B. But just because the area that's covered doesn't necessarily mean that these spinners are fair. It might be that the weight of one corner is heavier and it tends to fall on that number more than others. So what we need to do to check whether we have a fair spinner is throw it enough times and see what the results are and compare that with the theoretical or expected results and see how far apart they are. So if a spinner were fair and I spun it 100 times, then I would expect to get equal results for each number, if it were fair. So if it was 100 goes, then I would expect a frequency, so we call that expected frequency, to be 25. Now it doesn't mean that if we don't get that, the spinner is not fair, but we should get something close to this. So it's a bit like saying if I tossed a coin 100 times, I would expect 50 heads, but in reality I might get 43 or I might get 52. If I've only got 3 heads and I tossed it 100 times and I got 97 tails, then I'd know there was something unfair about the coin. So let's have a look at the results we got then. So in spinner A, I've got 23, which is 2 down from what I'd expect. Spinner 2, I've got 27, which is 2 up from what I would expect. And then spinner 3, I'm 3 down, and spinner 4, I'm 3 up. So there's slight differences. So there's nothing really here to suggest that there's anything unfair about this spinner. So I would say results close to the expected. Get that onto the screen. Results close to the expected, so spinner is fair. Okay, and if we come to spinner B, then we're going to see that they're nowhere near close. The 1 has come up 80 out of the 100 times. It's come up 55 times more than we expected. The 2 has only come up 10 times. That's 15 down on what we expected. The 3 has only occurred 8 times. That's 17 less than expected. And the 2 is 23 less than expected. So really there's definitely bias here towards the 1. The 1's coming up 80 out of 100 times or 8 out of 10. So this spinner, in terms of each number having an equal chance of being selected, is not fair. So this is an example then where we are calculating relative frequencies. In terms of that, the relative frequency in terms of a probability, the probability would be 23 from 100, 0.27, 0.22, 0.28. So this is the probability that it comes up in one throw, and they're all very close to what we'd expect. The expected, if it's fair, then the chance of an X occurring would be 0.25, X being 1, and it would be the same for all of them. If it's fair, they all have an equal chance of coming up. So the relative frequency bit is to simply take the 23 from its total of 100, and then you've got the relative frequency here and the expected frequency, or the expected probability there. All right, or you can simply look at the numbers as I've done in the question. So from everything we've seen, the probabilities are very similar, the relative frequency very close to the expected frequency in one throw. Okay, so that's looking at whether spinners are fair using actual results compared with expected results.